Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Mateusz Wojtczak is a Google developer expert in Flutter and Dart. He's co-founder of Flutter Warsaw and a developer at LeanCode. He will talk about testing apps with Patrol. Let's go!
Hi everyone, welcome to the talk about Patrol, Flutter First UI testing framework. I'm Mateusz and I'm head of mobile at LeanCode, one of the authors of Patrol, and right now in the role of technical product owner, overseeing all of the technical decisions regarding Patrol. Also, I'm a Google developer expert in Flutter and Dart, and you can find me on X at this handle. So, if we want to talk about solutions, let's talk about the problem. So the problem is that there is no good enough Flutter UI testing framework in the market. And what it means, no good enough. So actually this problem consists of a couple of problems. So the first problem is with native automations. So your Flutter app is also a native app, and whether it's Android or iOS, eventually you would have to interact with some native elements. For example, you could have a permission dialog in your app. You could have a third-party SDK involving authentication flows like sign in with Google or sign in with Apple. You could have a web view with authentication. You could have, for example, things that block your critical business path, like third-party payments SDK, like PayPal, for example, and they are all native. And to proceed with testing some business case scenario, you have to go through it if you want to perform a real end-to-end integration test. So with official tooling available from Flutter, like integration test, you cannot do that. You can only interact with Flutter views, widgets. You cannot interact with native views. You cannot allow the permission. You cannot click on some PayPal native view, stuff like that. So this is the first problem, but while resolving the first problem, we also discovered another one, which is developer experience. So if you look at the code on the left, you can see that this is the test written in Flutter test, like a widget test that only what it does is entering text in 3 text fields and tapping on 2 things. So it's actually there are 5 actions, and to perform that we have to execute a lot of lines of code, and it's really hard to read. It's cumbersome, and also you have to as you can see, there's a lot of boilerplate. You have to use tester anywhere. You have pump and settle every other line, and we thought, okay, maybe it's a great low-level framework, but we could have something more high level that's more comfortable to use every day and also easy to read and write. And on the right side you can see the example of a complex finder in Flutter test, for example ancestor and descendant, which is really unintuitive. Like, you have to think what it means, and then after some time you will know what you actually had in your mind when you wrote it. So, but it's not only that, because last but not least, there's also a problem with CI/CD and device farms. And why it's important? It's because if you want to have any end-to-end integration testing involved in your application, there's 90% chance that you also want to execute it on some device farm, probably physical device farm, or your own CI/CD pipeline. So what's the issue with that? There are a couple, actually. There are no test durations, which means that as you can see, the red arrow, you always see less than 1 second when you run official integration tests on some device farms or CI/CD. There is no isolation between tests, and you have slow and redundant builds. So what it means? So slow and unnecessary builds mean that if you have multiple files with your tests in integration tests, you have to build each file separately. So you have if you have n files, you have n APKs, and the device farm wants you to upload one APK for the app and one APK for the tests. So each run would have to be separately run and uploaded for each of those APKs. So the first thing is that it costs you time and money because you have to build it somewhere on some CI/CD or somewhere else. And also it's unnecessary because you build multiple times, it's slower, and you have to execute it multiple times, so it's also slower. But there are some workarounds that you probably have in your mind, which is, for example, okay, so let's take all of those files and just import them in one file and run it. And it's really a good idea. And we call it a primitive test bundling because it actually bundles tests. And you have one APK, so it's solving this problem. But it seems to work fine if you have, for example, 4 files, and in one file you have a failure of the test, which is just because you have the expect or stuff like that, expect true false, and it's just a legal failure, I would say, and it gracefully fails with a result of failure. Then you are okay. You have 3 past tests and 1 fail. But what if we have a crash? So something like, you have a process and you just exit it. So something goes really wrong, and in your second test it crashes and you have a kaboom. And naturally you would expect the rest of the tests also to be executed in isolation because it's not related, right? But actually when you run it in this primitive test bundling approach, you bring down the entire test suite. So if you have 100 tests and after 99th test you have a crash, then you don't have any results from those 99 tests. So also you have no test durations, as I said before. For example, Firebase Test Lab works with integration tests, but the native tests are created and completed only after Dart test run. So as you can see, you have less than 1 second. Also, you have no sharding, which is that on some device farms, sharding means that the farm can split your tests into multiple shards so that it's faster because you can utilize more machines. So what can we do, huh? Okay, so have you heard of Patrol, right? So what's Patrol? Patrol is a Flutter First UI testing framework. What it means is that it's Flutter First. What it means is that it's written in Dart. It's Flutter First, so it's meant to work with Flutter apps, and Flutter apps, in our opinion, are 90% of Flutter code and only some 10% of native code that you just want to be able to interact with, but it's not your typical use case, right? Your typical use case is that you have to be the most comfortable with working with Flutter widgets. So it has to be intuitive for Flutter devs, it has to be written in Dart. And it uses Flutter Test for Flutter features because Flutter Test is the best low-level SDK for interacting with widget tree, in our opinion. And we also leverage XCUI Test and UI Automator for native features, which are official first-party SDKs for native UI testing. Also, we try to offer smart defaults and intuitive API. What it means, you will see that most of the times some QA people tell us that okay, usually we just want to have we just want to try and tap on the first result that we find, for example, on the screen. So we try to also reproduce that logic of smart default to reduce boilerplate and just to, because 90% of the code of integration tests is pretty much similar, and we try to take advantage of that. And we want to be compatible with device farms and native tooling. What it means that if we are run as a native test, and we are, so we can be seen as an Android test or iOS test, then we can be just compatible with any device farm that's compatible with Android and iOS, which is really important because we as Flutter community deserve to be compatible with such tools. And the problem is that if they have to support Flutter explicitly, then it will take a lot of time when all of those farms will migrate and incorporate some native support for us. But if we reverse that dependency and we just will be seen as a native test, then we can be run from any tool from day one. That's what we do actually. Okay, so let's take a quick look at the architecture. So we have actually two packages, one plugin, which is Patrol, and it replaces integration test. It's all about this native integration. And also we have a Patrol Finders package, which is just a Dart package with high-level Finders API. So you can use Patrol Finders in your widget tests, in your golden tests, anywhere where you would use Flutter test. And it's not related to native platforms at all. It's not related even to the platform. So you can use it if you have Flutter Web or any other stuff. And Patrol if you want to have this native sauce. So pretty standard adding the package to the pub spec file. So Patrol Finders for the dollar, as you will see in a moment, and Patrol for native automations. So what's Patrol Finders, right? There are finders that we try to extend Flutter Finders, Flutter Test Finders, not replace them. So you can use Patrol Finders wherever you would use a Flutter Finder. We also try to counter flakiness. So we try to check if something's visible, wait for it, check if something is clickable, like tappable, hit testable, to be exact. We try to pump and settle and stuff like that. They're faster and easier to write in our opinion. They are opinionated pretty much, as you can see. And we try to just take advantage of this concise syntax that many frameworks that find views in UI testing also have, like you would use jQuery from the old times. So as you can see, we have this $sign, which is callable object, and if you call it with type, you will have find by type. So you have a list view finder. If you call it with a string, you have find by text. If you call it with a symbol or a key object, you have find by key. If you call it with icon data, you have find by icon. And if you call it with a regular expression, you have a find text containing. All right, so we have a couple of smart defaults, as I said. So we already provide some methods for you, such as tap, long press, enter text, as you can see. And also, as you can see, we don't use tester dot convention. Rather, you have a finder dot tap, finder dot add. You have wait until visible, which means not wait until something is in the widget tree, but until something is actually hit testable, so we can tap on it. You have dot add, which is, for example, in here, find fourth icon button. We have scroll to, which is really smart, because if you use it like here, MyKey.scroll to, we will try to find some scrollable that's there and try to scroll this scrollable until this MyKey finder will be seen like a visible, so you can tap on it, and then dot tap. And also we have which is pretty much the same as a widget predicate from Flutter test. Okay, so let's try to rewrite the code from the first slide, and as you can see, we can achieve actually 7, I think, lines of code. So we pump widget and settle in a pretty standard way, like you would do with Flutter test. And then we find by key, enter text, enter text, enter text, 2 taps, wait until visible, and voila. Okay, so what's about those complex finders like descendant or ancestor? Okay, we also have methods for that. So to find subscribe text inside the list view, you can use $. So if you use $, is the same as a descendant. So here you find a list view and a subscribe inside it, and you tap on this subscribe text. And it's not only that, it's not only the simple translation, because we also do a lot of stuff that you don't want to do, such as waiting for the list view to be visible, waiting for the subscribe to be visible, and stuff like that. The same goes in the other direction. So this is more complex, like to read the left side, but with the right side syntax is, I guess, easier. So if we want to have something that's, we have a list style, it contains activated text, and we want to find a list style that contains activated text, but we don't want the text but the list style itself. So we want to find a child, but actually we want its parent. Then we use dot containing, and this is the equivalent of ancestor. So in this right side code, we find a list style containing activated, and then we find learn more key inside the list style and tap on it. Okay, so remember that the default tooling is still available. So what it means is that you always have you always have dot tester, which is a classic widget tester. So there's always an escape hatch. You don't have to worry about that. If you go with patrol, then and in patrol has any bugs, then you can't go back. You always can use just plain old widget tester. We extend, not replace. Okay, so let's go to the main course, which is patrol, and it uses patrol finders and adds this native interaction sauce. So patrol, as you can see on the right side, we just add .native. This is really important to just to differentiate features that are Flutter related and native stuff related. We use .native. Everything that's in .native object is native, and this is related to native platforms, native interactions, and integration testing, end-to-end testing, because finders without native can be even used in widget tests and golden tests. So as you can see, we also support some native features from day one, like enable cellular, disable Wi-Fi, toggling system theme, handling permissions, tapping on notifications, stuff like that. And basically everything. So with Patrol is the first framework when you can write only Dart code and interact with native stuff in your end-to-end test. This is really important. So let's look at the features that we already have out of the box. The first one is notifications. So with this simple code, you can, for example, grant permission when in use. Grant permission when in use is a generic method. It's not only for notifications. It can work with any kind of permission. We can press home. We go to the desktop or launcher. We can open notifications tray and tap on notification by selector. Selector is kind of a finder, but on the native side, we didn't want to confuse you with the same names, so we choose a different name, which is selector. Okay, generic permissions, so we can deny, grant the same way. And actually we can test everything. So what it means is that you always have .native tap, .native enter text, .native swipe. So you can just interact with any native view that is in native view hierarchy. So as you can see, we can create a contact in Google Contacts application on Android, which is not our application, is not developed by us, it's not installed by us. But when we are in this blessed instrumentation view on both Android and iOS, we can actually interact with any other app, even with launcher and system apps, stuff like that. But moderation is a virtue. What it means is that you shouldn't do that. It's flaky. This app is not yours. You cannot be assured that this API that it exposes is the same on every device and stuff like that. But there are some cases when you just want to be able to do that, and we offer you just to be able to do that, okay? Alright, so how to install Patrol? You have Patrol CLI, you activate it as any other global Dart tool. And we have a couple of commands. For example, we have Doctor, which is like Flutter Doctor, because we require you to have some things installed like Java and Xcode build, stuff like that. And we also have a develop mode, which means that you can take advantage of the hot restart, which is in Flutter, not hot reload, because in tests hot reload is not so much, I would say, helpful because you are already at the end of the test, so you want to rerun the whole test. So to develop tests, you can use patrol develop, and then you can use patrol test. There's also patrol build to build the APKs for your device farm. We also have a DevTools extension so that you can see native views. So if you want to know, okay, so what's the ID of this native view? I don't know what to tap on, what to write in my selector. You can use our DevTools extension for that. And also it works on device farms. So this is the video of our example patrol app that's automatically executed on Firebase Test Lab from our GitHub repository. So as you can see, it just works as some Android or iOS app. Patrol is open source, licensed on Apache. We have docs patrol.leancode.co. We develop and maintain it. We do it also from our purpose because we test several production grade apps with it, and it's free because people ask me often about it. So last but not least, we as LeanCode are a Flutter agency, and we also offer help with patrol. So if you want some free patrol consultation, you can use this QR code. You can also hire our QA patrol engineers, because I know that many developers don't want to write end-to-end integration tests themselves. And also, last but not least, we offer Flutter development services such as architecture, design system workshops, or just to be a sparring partner for you and talk about Flutter with you. Okay, thank you very much. You can help us, you can give us a like on Pub, you can give us a star on GitHub, follow us, or join our Discord and use our package. Thank you very much.